Rahim. Assalamu alaikum dear students. This is our next problem having been chosen from the same book Modern Physics by Stephen T. Thornton and Andrew Rex. This problem is to some extent similar to our previous problem. Moreover, dear students, it is important to point out here that we have already solved some similar problems, to some extent similar problems on the same topic, but those problems were from the book either Modern Physics by Kenneth S. Crane or Modern Physics by Paul A. Tipler. But now we are following the book Modern Physics by Stephen T. Thornton and Andrew Rex. Okay, so it should be quite clear that no problem is repeated throughout the channel. If problem seems to be similar to some other problem, to some extent, even then it is 100% sure that a similar situation is being used from some other book with different numerical values and different wording. However, overall framework of the problem may be similar to previous problems. Okay, anyhow, for the time being we are following the book Modern Physics by Stephen T. Thornton and Andrew Rex. As usual, we first come to its statement. Okay, in an other universe where the speed of light is only 100 meter per second, an airplane that is 40 meter long at rest and flies at 300 kilometer per hour will appear to be how long to an observer at rest? Okay, this problem is to some extent similar to previous problem, but despite this, this is other problem of the same book. Okay, now we come to its solution, but before solution we are going to introduce several snapshots which have been chosen from different books, and these snapshots will provide a foundation for our understanding in the matter. Okay, so first snapshot is about length contraction, and because this snapshot has been discussed in previous problem, so we just include this snapshot in this problem because it is also relevant in the same way as it was relevant in the previous problem, but we do not discuss it in detail. Okay, similarly, second snapshot, which is about Lorentz factor, has also been included in several various problems, so we also skip it. Okay, now we come to solution in a proper manner. Okay, first we are going to find out the value of gamma, which is Lorentz factor. Okay, which is called Lorentz factor. Lorentz factor gamma is equal to 1 over 1 minus u square over c square. Here value of u is given in the statement as 300 kilometer per hour, but here we have converted kilometer into meter and hour into second. Okay, so 300 kilometer has been converted into 3 into 5 times 0 meter, divided by 1 hour is converted into 3600 seconds. Okay, 60 into 60. moreover, value of c, speed of light, is not here going to be taken standard value. We are not applying standard value of c, which is 3.0 into 10 raised to the power 8 meter per second, or sometimes 2.998 into 10 raised to the power 8 meter per second, while we are using its value as 100 meter per second, which has been assumed to be an alternate value of speed of light in this specified problem. Okay, so we are not using standard value of speed of light, we are using the value of speed of light as has been proposed in this problem. Okay, so dear students, next, just a simplification. I am not going to explain this simplification because this simplification is just school level mathematics, and if I explain it step by step, it will almost amount to wastage of time. Okay, so our Lorentz factor gamma has finally become equal to 1.795. Now, using L equal to L naught over gamma, okay, length contraction expression, which has also been included in a separate snapshot regarding this topic. Okay, so L is equal to L naught over gamma. L naught is given as 40 meter, while value of Lorentz factor gamma we have calculated in the above previous step or above step, this 1.795. okay, so this simplification will lead to L equal to 22.28 meter, 22.28 meter, and this is the end of our problem. This is the end of our video. Till next video, Allah Hafiz.